Okay, I'm Patrizia. I'm a scientific officer at the Joint Research Center at the European Commission, and today I'm going to show you part of an ongoing research project that is articulated in two phases, and I'm going to illustrate you the first phase. We were interested in understanding if there are patterns of similarity within and amongst European cities in terms of spatial location of urban amenities, the impact of amenities distribution on the vitality and the rhythm of cities, and also the attempt at urban space according to amenity distribution. So the data that we are using are POI sourced from Google Maps in 2018 from the European capital cities. All the amenities are actually coherently categorized across the cities, but we divided the 4+ different typologies in macro categories for purpose of analysis and evaluation of results. And also the POI were joined, grouped, and analyzed using a grid of 500 square meters. And as for the methodology, we use an unsupervised machine learning technique, detecting the patterns in the distribution of amenities in urban space. Now we are actually analyzing the two different kinds of data. So we are analyzing spatial data, spatial information. So for spatial similarity, we use a discrete distribution of amenity and Jensen-Shannon divergence as a distance metric. And then for temporal similarities, we cluster the affluence of people because we also had access to hourly time series of affluence of people to amenities. So we clustered those using dynamic time warping as distance metrics, and we use Dbscan as a clustering algorithm. As for the results, in the first lab, see spatial pattern of similarity across a number of different capital cities. So you can see that the spatial patterns are coming out of the analysis, and for each cluster we can actually plot the distribution showing the typology and variety of different amenity typologies present in each area. Now, for example, if you took a couple of cities like Stockholm and Dublin, you can see that there are similar label are placed like in the center of the city, and then there is a more variety across the outskirts of the cities. For example, the label that cluster around the central area of cities, you can see that there is a variety of amenities, so presence of different typology that can actually attract more people during across the day, so during different time of the day, increasing the presence of people in the place. Then if you move in the outskirts, you can see that actually the specialization of the areas increase. So there is the a specific type of amenity that is actually characterizing the area. Now, because we didn't only have access to spatial information, we also had access to the hourly trend of the affluence in the typology, in the different amenities. We can also actually cluster based by affluence of people in the amenities. Here is an example for Paris, and we actually were able to add weekly patterns of affluence. You can see at the left side an example of how different areas are characterized by a different temporal trend during the day. This is a weekly average day, but because we had access to to the data for different days, we can also cluster and add the results for different days in the week, like for Monday and for Friday, and observe the variation of the temporal trend and the variation of use of places by people during the week. For example, on Monday and on Friday, you can see that there are similar patterns around the center of the city, and you can have a look at the temporal trend below, What is interesting is that if you move from Monday to Friday, you can actually observe at the center of the city a drift towards a more specific temporal trend, identifying usually the nightlife or the weekend temporal patterns, with a peak around 8 o'clock, so around the late hour of the evening and then the night. So we analyze, we run a cluster analysis, analyzing the land use, the urban land use at a higher resolution. We were interested on the impact of the diversity of amenities distribution, especially having a look at the vitality and the rhythm of the city. For example, the presence of people during day and night, the weekly routine, but also the loneliness of places in the city. It is worth mentioning that an average affluence trend, these are average affluence trend for each area, so regardless of the amenity type located there, and also because affluence is a value that's only applicable for the amenities, we must remember that we must be careful when we use it as a proxy for human presence in a place. And as for future work, we are going to run a cluster analysis for getting the similarity of the patterns across all. We also are planning to do a cluster analysis for specific urban domain, for example, only shopping activities, only leisure amenities, or public services. And later on, in the second phase of the research, we are going to compare these results with different urban features like population distribution, and also the structure of cities like monocentric city or polycentric city, and also possibly socioeconomic attributes, income or other social attributes derived from census, etc., coming from different European countries. Thank you.
Thank you, Patrizia. It was a great presentation. Any question? Okay, Kevin. First question is from Kevin. Could you clarify the source of the data, especially the temporal aspects?
Yes. So the data was collected using the Google Maps API in 2018. So as you know, Google Maps also includes temporal information about the opening hours of amenities, and in some cases, not all the cases, also the affluence. So they calculate an average affluence for each day of the week. And we use this data for running the temporal analysis.
Okay, the next question. Thank you for the nice talk. What are the selected clustering parameters for Dbscan?
Yeah, you mean, so we use Dbscan, not Dbscan, but Dbscan, which is similar to Dbscan, and we started trying to obtain a number of clusters that was fine enough to high enough to have a proper representation of the different trends and a proper representation of the different distribution for each cluster, but it was also still manageable in the evaluation of results. What I have to say also is that I've already used this type of data in my PhD dissertation. So I was already familiar with this kind of data, so it was also somehow easier to fine-tune the parameters of the clustering algorithm to get good enough results from the algorithm.
Okay, Thank you. The next question from Kevin. So it was opening, closing time, not check-in. Yes?
No. Well, yes. So it was the affluence. So it was the number of people in that place at that hour of the day. Clearly, if you have this type of data, you can also derive opening and closing time. No, it's not about, it's not a check-in data. However, Google collect this kind of data from people that search in its engine. Like if you want to go in a place, usually Google asks you, okay, how was the place crowded? Or and of course they collect other type of data from your phone, so they are able to calculate this kind of value. Again, it's an average value for an average day of a week. So the data that we collected in August 2018. The colleagues collected them in August 2018, so they are good. Well, they are reliable for that time frame.
Okay, thank you. Any other question? Okay. As an urban planner, I have a personal curiosity about your data. Do you think you can use this type of data to model neighborhood change, or I mean, identify neighborhood change in the big city?
Yes, I think so. In fact, it's the curiosity was about how the presence of certain amenities can actually have an impact on the vitality of the neighborhood or on the loneliness of the neighborhood in big cities, because here we are only speaking about capital cities in Europe. And yes, it's a type of data that should be exploited more in urbanism and urban planning to try to understand how the place work, how people use spaces, and also use the results to direct policies if you want to modify and intervene in the design and in the planning of a neighborhood.
Thank you very much. Actually, I have a research project on Dublin on neighborhood change. I wonder if you can share your data on Dublin with me or no?
Well, that's I'm not sure about that. However, please write to me so we can. I can at least I can give you more information about my work.